So we want to look at the link between carbon dioxide and surface temperature. And to do this, we want to go back in time. So on this vertical axis, let's plot temperature. And in particular, let's pin 0 to be the current average surface temperature of the Earth. On the other vertical axis, let's plot carbon dioxide, CO2. And when we start 40 million years ago in the Eocene, the climate then was very interesting. There are a number of paintings in museums across the world that depict what that situation looked like. First of all, it was much warmer. It was running about 8 degrees Celsius warmer than today. And that was true of the world's oceans. And it was true of the world's oceans all the way to the ocean bottom. Everything was about 8 Celsius warmer. It was also extremely wet. This is an example of what the central United States, now in Wyoming, which is very dry now, was extremely wet. But more than that, tropical plants and animals existed in the Arctic Ocean. That means that even in the coldest part of the winter, the temperature never got below 0, because those organisms, for which we have fossil records, would have died if that were the case. And they prospered. But more than that, the temperature difference between the tropics and the polar regions was very, very small. So the Arctic was virtually as warm as the tropics. But as time went on, our favorite reaction, the silicate reaction, drew CO2 out of the atmosphere, forming limestone. So as we move forward in time to 10 million years ago, 2 million years ago, that silicate carbonate reaction drew CO2 out of the atmosphere. And as CO2 decreased, so too did the temperature decrease. So we can track both of those because they track each other very closely. And we know that from a number of isotopic records and so on worldwide. But as soon as we reached the pre-industrial level of about 250 parts per million, then, as we've seen before, the glacial interglacial period, where we went from an ice age to an interglacial period similar to today, that oscillation was controlled entirely by the Earth's orbit. The carbon dioxide in the atmosphere was so small that it didn't exert powerful influence over the surface temperature. But as soon as we start to mine fossil fuels, natural gas, petroleum, and coal, the carbon dioxide concentration begins to increase. And as soon as we get above about 300 parts per million, the orbital parameters of the Earth exert far less control, and the control moves from the orbital structure of the Earth around the Sun to the trapping of infrared radiation and the increase in surface temperature by virtue of the infrared radiation that's trapped by CO2, water, and clouds. And so we're now in a situation where we have 400 parts per million of CO2 in the atmosphere, but we also have to count the additional contribution to infrared trapping from methane, N2O, chlorofluorocarbons, and that raises the effective CO2 concentration in the atmosphere to almost 500 parts per million.